know, for Module 5, Part A, we have about 2/3 we need to complete. But today, I want to directly go to Part B first, complex queries, because there are some topics about aggregate functions. That part you need to use in this homework assignment. Homework assignment number 2, Part B. There are a few questions. You need to use aggregate functions. And there are some basic concepts you need to understand before you can use the right way to do those queries. Okay, all right, yeah, so let's try to complete this Part B today. Okay, all right, so let me start Part B, complex queries. Yeah. Yeah. B.1, correlated nested queries. That's about the structure. Some queries relatively complex because the structure, like this one, inner query, outer query, and these two levels of queries are correlated. Yeah. So the inner query needs to refer outer query, certain fields from outer queries and use for inner query. That structure. Okay? Yeah. Some of the inner queries do not need to refer to outer query. Okay? Yeah. That kind of structure very easy. Yeah. But the correlation between inner query, outer query make it a little harder to understand and write the queries. First, let's study this type of queries. Correlated nested queries. The definition first. Whenever a condition in the where clause of a nested query references some attribute from a relation declared in the outer query. Yes, that's the main property of this type. The two queries are said to be correlated. So you need to really need to understand the correlation. Okay, so remember I talked about one concept before. One concept called tuple variable. Okay, yeah, think about. So there is a concept I talked about before called a tuple variable. Tuple variable. It's an imaginary variable. You cannot see it. Okay, yeah, you just imagine. It's an imaginary, hidden variable. Here, in order to understand this correlated nested queries, we need to use this concept again. Tuple variable. Okay. When I show you the example, I will explain that. All right. Understand correlated queries. We can understand a correlated query better by considering that the nested query is evaluated once for each tuple. So here, look at this tuple. Okay, point to that tuple variable. Nested query. All right, and inner, right? Inner query we call the nested query. Okay, inner query is evaluated once for each tuple in the outer query. Yes, so here, that's the structure understanding specifics here, we use this way. So let me explain this sentence. Yeah. All right. Yeah. Actually, the logic, you can use your experience when you do the nested for loops, right? Yeah. So I think you feel comfortable writing the code for the nested for loops. Yeah. Here, nested query, you can use the same logic, same approach. Yeah. So for nested query, so nested for loops, outer for loop, so you have a counter variable, right? That counter variable is carried inside the inner for loop, so then you do iterations, okay? And when you do inner iterations, the outer counter variable is fixed. Yeah, so when you do each iteration inside the inner for loop, so you fix that outer counter variable. Yeah, all right. Here we have the similar situation. All right. We start from outer query. Okay, the outer query. First, you need to go through all the tuples in the outer query. Okay, all right. So here, let me draw a diagram. Yeah. Similar to nested for loops. Yeah, but I draw a similar diagram. So when we start, okay, all right. So here we start from outer query first. Okay, outer query. So this is the table. Yeah, because our outer query, the query should generate a table, right? Or a query should work on a table, right? Yeah. So this corresponds to the outer query table. Outer query table, you have tuples. Your tuple, you need to go through each one, right? Yeah, from beginning to end. Okay, all right. But here, when you need to get into the inner query, so you need to select one of the tuple from the outer query. Yeah. So this one's we call the current. So this is the current tuple. Current tuple. Okay. All right. So now the current tuple. Yeah. So you can imagine it's a tuple variable. Okay. Yeah. Yeah. You take the current tuple, you carry it inside your inner query. Okay. Yeah. So now you need to get into your inner query or nested query. Okay. Your inner query, you also need to go through another table, right? Yeah. Row by row, tuple by tuple. Okay. All right. So, but when you go through the inner query row by row, okay. So here, look at it. Evaluated once. That nested query is evaluated once for each tuple. Each tuple in the outer query. Yeah. All right. So evaluated. Yeah. So here, actually, we should say evaluated row by row. Okay. Yeah. So here, when it's better to insert row by row. The way, okay? Yeah, yeah. So here I try to use two different terms to separate inner query, outer query. So this tuple, we refer to outer query, okay? Outer query tuple. So inner here I use this row by row, okay? Yeah. And when you evaluate inner query row by row, you fix the tuple you carry into the inner query. Okay? Yeah. Yeah. So that means for the same tuple you consider from the outer query, you do the evaluation for all the rows in the inner query one by one. Okay? Yeah. So, yeah. But evaluate, sometimes true, sometimes false, right? Yeah. And sometimes unknown. So only when your evaluation returns true Boolean value, you select it. Okay? Yeah. Yeah. Now, all right. So that's the, basic logic understanding. Okay? Yeah. So after that, we just need to, practice, build up experience. Yeah. Any and some in combined operators. Yeah, there are some, because there are several operators. Basically, they do the same thing. Yeah. So here, this any, some do the same thing. Yeah. So even from the language, similar. Yeah. But for the SQL, you can treat them as the same operator. Yeah. All right. So here, equal any or equal some. So that means equal any operator. Yeah. So you can use the meaning. You can say, one tuple equal any. Then inside you'll have a list of tuples. So equal any. All right. Yeah. Equal some. Yeah. And equal any. Equal any, equal some, the same thing. Yeah, just sum of the tuples in the list. Equal any, equal some. Okay, operator. Yeah. Equivalent to in. Yeah, so there is another operator called in. Yeah. So these three operators do the same thing. Yeah. But the most popular one is in. Okay. Yeah. The most popular and very useful operator is this in. Yeah. So the other two, equal any, equal some, you only need to know them. So if other people use these two operators, you know the meaning. Yeah. Yeah. For us, most of the time we use this in operator. Yeah. So this is a very useful operator. Yeah. The meaning is obvious. Okay, in. Yeah. Just the one tuple belongs to another table, okay? Yeah, belongs to, so that is one of the tuples in a return table, okay? Inner query return table, yeah. All right. Operators other than equal that can be combined with any or some and all, yeah. Greater than, less than, and combined with all. Yeah. So, yeah. So that's these cases. So when you see the situation right, so you can use the combined operator. Okay. Yeah. Yeah. But this time it's not equivalent to in. Okay. Only equal any, equal some equivalent to in. Yeah. And other cases, so you can see. You just based on the basic understanding. Yeah. For example, greater or equal to all. Yeah. For example, you may have greater equal all operator, right? Yeah. Now you can see the current tuple, its value is greater or equal to all the values in the list of the table. Okay? Yeah. So then the meaning, yeah. Yeah, greater or equal. Right. Straightforward, yeah, understanding. Yeah. All right, yeah. Let's look at this query example. Yeah. So this is a nested query. Okay? Yeah. Here the operator we are using strictly greater than. Yeah. Greater than all. greater than all, okay? Yeah. Not equal, so strictly greater than, okay? Not including equal, so strictly greater than, this time, okay? So here you can see the salary, the employee who has the salary is strictly greater than any employee in the department 5. See? Yeah. This example. Any employee, okay? Yeah. In the inner query, okay? Yeah. Inner query, you return salary. So the table contains the salary numbers for the employees in the department 5. Okay? Yeah. So then the outer query, the salary of the current employee selected. Current employee. Okay? Yeah. Now you check your operator. You run your operator. Okay? Compare the values. If the current salary number is greater than any of, all of, or greater than the maximum, equivalent. So you may, greater than the maximum of the employee in the department 5. So then it's true. So you return that employee information. All right, so this is our simple example. All right, next, B.2, aggregate functions. So that's the topic I want to give you explanation before you work on homework assignment 2, part B. So we have several questions. We need to use aggregate functions. But when you use aggregate functions, there is some concept you need to understand. Okay? Yeah. So let's study in this topic. Yeah. First, let's look at those aggregate functions. Oh, why? Yeah. Aggregate functions. Look at the meaning aggregate function. Summarize information from multiple tuples into a single tuple summary. Yeah. Aggregate function. Okay? Yeah. So you need to apply certain functions on multiple tuples and return a single value, single tuple value. Okay? Yeah. Examples. Yeah. We commonly use, these are the commonly used aggregate functions. Count function. Yeah. We used it before. Count function. Count the number of rows. Count function. Sum. Yeah. Similarly, so you can add up the values for a particular column. Yeah. Sum function. Max function. Min function. And average function. So these are the commonly used aggregate functions. Then, the most important concept you need to use when you do the aggregate functions, grouping concept. Grouping concept. Okay? How do you apply aggregate functions? Basically, you have two ways. The first way, you do not specify any groups. You do not define any groups. You just apply your aggregate functions directly. Yeah. When you do that, you treat the whole table as one group. So you apply your aggregate functions for that only group. That's the whole table. For example, currently, when we use the count function, we use that way, right? Think about when you use count function, you never define your groups. Okay? So if you do not define your groups, you mean the current table is the only group that you are using to apply your aggregate function. Okay? The default case. All right? Yeah? But many times, when we apply aggregate functions, we need to apply it on individual groups. we need to define many groups. Okay? So then apply aggregate function on each of the groups. And you return one value for each of the groups. One value. Yeah. So the whole query, you return multiple values. When you have multiple groups, you need to return the same number of values as the number of groups. Yeah. So that's the second way, the way you need to define groups. Second way is a little harder to learn, to understand. Yeah. All right, you need to build up some experience. Yeah. Grouping is used to create subgroups of tuples before summarization. Yeah. Before you apply aggregate functions, first you need to clearly define your subgroups. Okay? Yeah. All right. Subgroups. Yeah. All right. So here, regarding the grouping, this grouping concept, yeah, and we define subgroups. Yeah, here. Yeah. Let me use the concept. Let me use the partition concept to explain this grouping. Yeah. So let me see if I did it. If I do it in the next slide. Okay. Yeah. Yeah. I mean, how to define? Use group by clause. Group by clause. How to define groups? Group by. Following group by, you specify certain number of attributes for the group by. Okay. Yeah. Here the example. But before we go to the example, I want to explain this grouping concept a little bit. Grouping, actually what we are doing is partitioning. Partitioning, this concept comes from math. And set theory, we need to do partitioning. Set theory. Yeah. Here, let me explain the partitioning. One valid partitioning should have these properties. How to do one valid partitioning? You need to have these properties. Yeah. Okay? Yeah. All right. Because here we're talking about a set of subgroups. A set of subgroup. Okay? Yeah. So here, each subgroup, we can treat it as a subset in math. Subset. Okay? Subset. So here in math, we partition a set into subsets. Okay? Yeah. So in math, so our understanding is we partition a set, a given set, into subset. Okay? All right. Now let me talk about the properties. All right. The first property, each subset is not empty. Otherwise, it's useless, right? We should remove it from the partition, okay? Yeah. So each subset cannot be empty. Otherwise, we just remove it from the partition, okay? To simplify it, yeah. So non-empty. So this is property we call a non-empty property, okay? All right. Second, any two subsets do not overlap. The second property. Any two subsets. Sorry. Yeah. Any two subsets do not overlap. Okay, the second property. All right. The third property, yeah. The union of all sets is the same as the original set. Okay, so the union of all the subsets equal the whole set. Then, if you have all these three properties, you have a valid partition. Okay? Yeah. So, the last one, whole coverage. Your partition should cover the whole original set. Okay? So when you do grouping, when you define grouping, you also need to have all these three properties. Yeah. Usually we do not worry, okay? Usually we do not worry, yeah, because we automatically, when we use the group by clause, we have all these three properties, okay? All right. Next, let's look at this example. All right, a correlated nested query with an aggregate function. Question, retrieve the names of all employees who have two or more dependents. Here, two or more. Look at this condition part. Who have two or more. How do you know an employee has two or more dependents, right? So you need to use the count function, right? Yeah. So you need to know this aggregate count function. Okay? All right. Now, so this one is pretty simple. Yeah. Nested query, outer, inner. Inner, you need to count for the given, selected, current employee. You need to count how many dependents there is a dependent table, for this employee. Yeah. All right. Yeah. So the old version, new version. Yeah. Old version. Yeah. So old version means if we do not use the aggregate function. Okay. Yeah. We can do it without using aggregate function. That's the old version. Okay. Before we apply our aggregate functions. Yeah. So that is. So first name, last name, employee as E, all right, yeah. So you carry this current employee, yeah, this E, yeah. E dot SSM, that's the current employee's SSM, okay, yeah. So that tuple, that one is fixed. E dot SSM is fixed. Then we go through all the ESSN in the inner query, dependent table. In this inner query dependent table, all right? So we go through all the rows, row by row, in the dependent table and checking its ESSM value. And then we apply unique function, okay? Yeah, so there is a unique function. Yeah, unique, yeah. Because when you apply unique function, yeah, for the same employee if it has multiple dependents, then because the unique function only returns true if it has only one value. It is true. If it returns more than 1 or 0 or more than 1 values, then it's false. The unique function returns false. Okay? Yeah, here. Not a unique. Yeah. All right. Yeah. Yeah. How about 0? Right. Oh, yeah, there is something. Yeah, so here I noticed some logic issue, right? Unique. Not a unique. So here the meaning not a unique. Unique, if we understand exactly 1 unique, is it less than or equal to 1? Yeah. But here by logic, it looks like including 0. Because not, only when unique like this, not means greater than 1. Okay? Not means strictly greater than 1. Yeah. Otherwise, it may include 0, right? It may include 0. Yeah. All right. Let me double check it. Yeah. So here, the logic looks like that. Okay? All right. Yeah, but that's the old way. Yeah. That old way, avoid using count function. So you will see the old way is very limited. Very limited. Yeah. So the aggregate function, the count function way much better than the old way. Why? Because you can use count function, you can easily do change from 2 to 3, right? From 2 to 3. For count function, you just change one number. The count number greater or equal to 2, you change it greater or equal to 3. One little change. But for unique function, that is hard. You cannot change any number. Okay? So the older way usually is not very good, not very strong, powerful. Okay? Yeah. All right. So the new way, this time, our inner query, we apply another select statement, and we use the count function to count the number of rows satisfying the condition. Yeah. Outer query SSN equals the inner query ESSN. Yeah. Outer query SSN, we fix it, right? Yeah, we fix it. Yeah. When we do inner query, we fix the SSN value. Yeah. For the same employee, it may have multiple dependents, right? Spouse, children, certain number of dependents. So we count that number. Yeah. That number, we do comparison, should be greater or equal to 2, then it returns true, so this employee is selected. Yeah. So that's the simple logic. Okay? Yeah. 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 So this one, much better than the first version, because this 2, anytime if we want to change to 3, it's very easy. Right? Yeah. 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 All right. Yeah. Next example, maximum minimum function. Yeah. Can be applied to a set or multi-set of numeric values. Yeah. Here you can see. Yeah. Oh, numeric value is the first case. Yeah. Do not treat they can only be applied to so this is the first case. Okay? Yeah. First case. We have other cases. We have several other cases. Okay? The first case, numeric values. Yeah. All right. Can also be used with attributes that have non-numeric domains if the domain values have a total order among one another. Yeah, string values, alphabetic order, right? Yeah, string values, there is total order, alphabetic order. Yeah. So you can do comparison. you can get a maximum and a minimum. Okay? Yeah. And the date value, how about date values? Date value, we know how to do the comparisons. Date values also have a total order. Okay? Yeah. So you can apply max and minimum function. Yeah. Total, yeah, so here, every two elements can be compared in one of the three cases. Yeah. I explained the last time, the total order concept, and also partial order a little bit. Yeah. So here, yeah, we need to use that. Yeah. All right. Yeah, total order and a partial order. Yeah. So in this class, we will not have the partial order case. Yeah. So usually in your everyday life, it's very rare you can see the partial order case. Yeah. Yeah. It's very rare, you know, in our SQL field. Yeah. But in other field, in graph theory, in computer graph theory, then you will have a lot of partial order situations. Okay? Yeah. All right. Yeah, so here, partial order, yeah, I talked about this transitivity property last time. Yeah. So here, I do not need to explain it. Okay? I gave you a simple example last time. Yeah. So that's enough. Yeah. All right. B.3, partition for grouping. Yeah, so here, I already explained the partition concept. Yeah. So here, let's look at a few examples. Yeah. So if we see the concept, so we may skip. Okay. Partition concept for grouping. Partition a relation from math, partition of a set. Math partition a set into subsets. I already explained, right? Covering the whole set, the union of the subsets equals the whole set. Yeah. I talk about our third property. Yeah. Non-overlapping, our second property, non-overlapping. Yeah. Yeah. Intersection of any two subsets is empty. And a non-empty, our first property. Okay? Yeah. So that's the, partition, original meaning. Yeah. Groups and grouping attributes. In our SQL, usually we do not worry about if the partitions are valid or not, because if we use our usual grouping way, so they automatically have the valid partitions. Yeah. Partition a relation into non-overlapping groups of tuples. Yeah. How to partition a relation? The group by clause, here. Each group will consist of the tuples that have the same value of some attributes called grouping attributes, specified by the group by clause. Yeah. For example, here, select department number, and we also count. Yeah, we apply. So here, yeah. So this simple, short example. So let's look at the meaning. Yeah. Select. Yeah. So here, from employee table, we want to select department numbers. Yeah. And we count the number of employees in that department. And we also want to calculate the average salary for that department. Okay? Yeah? How to do that? So then, here, let me draw a diagram. Suppose this is the whole employee tables. That's our whole employee tables. Okay? Yeah. Whole table, remember, we have 40 rows in our company database. 40 rows, we have 6 departments, right? Yeah, total, we have 6 departments. So here, we use group by department number. Department number, the values of the department number is used to define subgroups. to define subgroups. Yeah. When department number equals 1, that's our subgroup 1. So let's call it D1. Okay? D1 group. So all the employees that belong to department 1, they form the first group, subgroup 1. Okay? And so on. Yeah. D2, dot, dot, dot. The last one, D6. Okay? Yeah. So there are 6 subgroups. Then, when we apply these 2 aggregate functions, one is the count function, another is average function. When we apply these 2 functions on each individual subgroups. Yeah. On D1, we apply once. Okay? So we return one number here, one number every salary corresponding to the department number. Okay? Yeah. D2, apply count function, average function, then corresponding to the department number 2, and so on. Okay? Yeah. So that's the typical way we use the aggregate functions. And we need to define subgroups in this example. Okay? Yeah. So you try to understand this approach well, because in many queries you need to do in this way. Okay? The grouping in this way. Yeah. All right. Next example. Null value in grouping attribute. Null value. Yeah. So you need to consider the special situation involving null value. Yeah. Because the way to deal with the null value is quite different. Yeah. It's a irregular value. So the way you handle this irregular value is different from the way you handle the regular values. Yeah. All right. Yeah. So let's look at the rule. If nulls exist in the grouping attribute, then a separate group. Yeah. So a separate group is created for all tuples with a null value in the grouping attribute. Yeah. So you put all the tuples with null value in the same group. Same group. Yeah. So other tuples with the regular values, then you use our usual way. Okay? Yeah. Normal way. Yeah. All right. Question. Example. How many employees are supervised by each supervisor? Yeah. So let's look at it. Yeah. So we still work on the employee table. Yeah. This time, we want to look at each supervisor. How many employees are supervised by each supervisor? Yeah. Here you can see we should use the supervisor SSN number to define groups, right? Or subgroups. Yeah, the same thing, subgroups. Groups, subgroups, same thing, okay? Yeah. Then we count. So we count, we apply. Yeah. Here, we count SSN. Yeah. From employee group by super underscore SSN. Remember our super underscore SN, there are 7 employees whose super underscore SN have the null value. Among total 40 employees, there are 7 of them with null values in the super underscore SSN. Okay? Yeah. So now you can see the first group. First group, it returns 7. Yeah. That corresponds to those employees with the null value. okay, with the null value. Yeah. And all the remaining for the normal, regular, super underscore SSM values. Okay, yeah. So this one supervises 3 employees, right? Yeah. Next one's 3, and so on. Okay, yeah. And some supervise 1. Okay, only 1 employees, and so on. All right. Yeah. Yeah. See. Yeah. So that here you can see, the special way we use to handle the null value in grouping. Yeah. All right. Yeah. Next, join condition in conjunction with group by. Yeah. All right. So after you feel comfortable using the group by clause to define groups, yeah, then so you can, create many complex queries, related to the grouping aggregate functions. Yeah. Question: for each project, retrieve the project number, the project name, and the number of employees who work on that project. Yeah. Aggregate function, right? Yeah. Each project. So you know how to define groups. You can use project to define groups, right? So each project that corresponds to one group. Yeah. Retrieve the project number. Yeah, you need to use project number to identify that project. The project name and the number of employees. That's the aggregate function you need to use. Number of employees who work on the project. The aggregate function. Okay? Yeah. So let's look at the query. Yeah. Here we need to use 2 tables: the project table and the works on table. Okay? Yeah. The project table, we can get a project name information. Yeah. And when we join these 2 tables, P number in the project table equals P null in the works on table. So you join 2 tables. Yeah. After you join the table, yeah, so you get a whole joined table, larger whole joined table, right? Yeah. But next you need to define groups. Yeah. But here to define groups, this way actually, yeah. So look at this way. We use 2 attributes: project number and a P name, project name, comma. So 2 attributes. Yeah. It's legal, 2 attributes. But the question is, why we use 2 attributes here? Yeah. Why we cannot use just 1 attribute, right? Yeah. Because we know the project number is unique, right? Yeah. Project number is unique for projects. Yeah. Yeah. Okay? Yeah. So that means if you use P number, it's already enough to identify the project. Why you need to use the P name? Okay? Yeah. So here, actually, I feel it's unnecessary. Okay? Yeah. Unnecessary. Yeah. So when you write a query, yeah, for things like this, sometimes people do some unnecessary things. Okay? Yeah. So unnecessary things, you first make your query less readable. Yeah. So if you add a lot of redundant information, so you make your queries less readable. Yeah. Second thing is, you may slow down the response time, performance, query response time. Yeah. Because if you put 2 redundant information there, yeah, so you may slow down the query response time. Yeah. So try to, avoid redundancy in your queries. Yeah. So here, yeah, because why we need to include project name, right? Yeah. P number is already enough to define our groups. Yeah. So usually when you use two attributes, yeah, so usually if you use the first attribute, it's not enough to define your groups. So you need to use the second attributes to narrow down, okay? Yeah. So to make smaller group definitions, yeah. Because yeah, here, I still draw a diagram, okay? Suppose, so if we start from the first table, okay? Yeah. If we use attribute 1, yeah, suppose attribute 1, attribute 2. So we define our groups. Attribute 1, yeah. Suppose attribute 1, yeah, A1, A2, A3. Okay? All right. Then, yeah, because attribute 1, after you define the first level, you use attribute 2 to define second level. Okay? So you do further split inside attribute 1, further split inside attribute 2, further split inside attribute 3. Okay? All right. So like A11, yeah, for example, A11, okay? A12, A13, and so on. Okay? Here, A21, and so on. Okay? Yeah. Yeah. So that's the typical way when we use more than one attributes to define our groups. Okay? Yeah. So like this. Yeah. And here it's not that situation, right? Yeah. Here, project number, so each project inside that project. So do we want to use project name to further split that group? Right? Yeah. So it does not make sense, right? Yeah. So here, you can see, even based on the, multiple attribute usage understanding, yeah, the second attribute P name is not necessary. Okay? All right. Yeah. So that's this example. Yeah. Next one. Yeah. Yeah. All right. Yeah. So I already yeah. All right. So in this case, the grouping truncation apply after joining of two relations. Yeah. Function. Yeah. Grouping and functions are applied after. Yeah. Okay. Yeah. All right. Same as, yeah, so here, all right, so here I simplified that second attribute, yeah, all right. Then, the last topic I want to explain, inner join, outer join, okay? Inner join, outer join, yeah, some students, here I noticed some students, they have some SQL experience. Yeah, yeah. So they have their SQL experience. Yeah. So when they write the queries, yeah, so sometimes they use inner query, sometimes they use outer queries. Okay, yeah, yeah. But I also noticed sometimes they may not use the outer query in the right way. Yeah. Outer query we need to consider. So you need to ask yourselves, why you need to use outer queries, right? Because our inner query, that's the default queries. Inner query, that's the default. Sorry, not query. Inner join, outer join, yeah. I used the wrong word. I should talk about inner join, outer join, not inner query, outer query, okay? All right. Inner join is the default join. Yeah. Outer join, so when you use the outer join, left outer join, right outer join, you need to ask this question. Why you need to use left outer join, right outer join, okay? Sometimes it may not be necessary. Sometimes you just only need to use the inner join to do the work. Okay? Yeah, all right, yeah. But this topic, I can delay the next time. Here, I have 10-something minutes. I want to show you the demo of the project. So I want to give you our second, a sample project for our second programming project, yeah, to get you started, to get you started a little faster. So I give you a few sample projects, yeah, so and explain. So you try to learn as fast as you can. After you understand the code, then we can do a few new features. Yeah. So today is the first sample project example. Yeah. So let me, I will upload the code. Yeah. I haven't uploaded. I just, get it ready. So here I want to show you a demo. Yeah. Simple demo. The demo is very simple. Okay. So here I want to show you. Yeah. We only have 10 minutes. I just want to use these 10 minutes. I do not explain the code. I just run it, okay? I want to show you the details, how to run this sample project example. Yeah. Here I use NetBeans. Yeah. So if you use a different IDE, yeah, so you just need to make it work. Here I use NetBeans IDE, so I show you all the necessary steps we need to run this project. Yeah. So after you download my code, so you can run this example by yourselves. Yeah. But make sure you install the XAMPP. Okay, remember? Yeah. Although I didn't post tutorial, yeah, because here you just based on the current situation, you just download the most recent version of the XAMPP. Yeah, yeah. Because here on my laptop, this one, the laptop I'm using right here, I use the most recent version of the XAMPP, and it works well. So, yeah. So if you use the current version, it should be fine. Yeah. Only when you have some problem you cannot solve, you can let me know. I try to help you solve the problem. Okay? Yeah, so, all right, so let me just get out my, all right. All right, so here, my NetBeans is ready. Yeah, so I only create one project, Hello World, okay? Yeah, so this is the project, I just created. Hello World, index.php, I type Hello World, okay? Yeah, so I test it, it works, so we can run other projects, okay? All right. Now, before I run it, I need to start my XAMPP control panel, okay? Yeah. Then I need to start Apache server. Click Start button, yeah? So you see port 80, yeah, so these numbers, yeah, so it's running, yeah. MySQL database server start button. Yeah. You see 3306, no errors. If you see no errors, some students you may see some errors. Yeah, because the most common mistake, because on your computer you may install another instance of MySQL, so the port number already occupied. Yeah. Because when you learn other courses, you may already install another copy of MySQL, a different copy running, yeah, and it keeps running. Yeah. So I saw that situation before. Yeah. Yeah. Last semester, yeah, last few semesters, I saw that situation. Okay. Yeah. So some of you may encounter that situation. Okay. You can let me know. Yeah. All right. Now, before I run, so here, first let me do a small testing. I just run my Hello World index.php. Yeah. Yeah, here I run it directly. Right-click this file, and click run. Yeah. See, hello world. Okay. So my web browser brought up hello world. Okay. Yeah. So that's the, first one. So first we know Apache is running, right? Oh, yeah. Oh, another thing. Yeah. I need to. Yeah. Let me see. I need to. Yeah, because although Apache is running, we need to access. MySQL database, right? Yeah. So here, localhost. Yeah, localhost. Okay. Because Apache running at the localhost. Okay. Yeah. Apache running at the localhost. Yeah. So here, we need to run. Look at MariaDB. Yeah, but actually it's MySQL. All right. Yeah. Menu. No. What's that? Yeah. Because look at this tab, PHP MyAdmin. That's the one I need to use to manage my MySQL database. Oh, yeah. Why not working? Oh, yeah. It's a little slow. All right. Yeah. Then now I click a databases tab. Yeah, because I need to install the database. I will give it to you. Yeah. Let me find my database script. Yeah. All right. Yeah. So here. Yeah. Let me find the database script. Okay. All right. Oh. Hey, where is it? All right. Yeah. Here. Notes. Here. Yeah. Part A. Do I have it? Oh, yeah. Sample project. Yeah. Look at this page. Yeah. These two files I need to upload to give it to you. All right. So universitydb.my.sql. This is the database file we need to use. Yeah. First, let me create a database. So the database name should be the same as the file name, universitydb. Yeah. No extension part. Yeah, because that's the database name I use in my code. Okay? All right. So let me create universitydb. This is my database name. Okay? University, I hope my spelling is correct. Universitydb. Create. So I create an empty database here, UniversityDB. It's an empty one, okay? Then I click SQL tab. I need to run the SQL commands to populate this database. So I need to open it in a text editor. Okay, yeah, here, this is the database content. Let me copy, paste. Copy, okay, paste. All right. Copy first. Then paste here, okay? Paste here. All right. Then click a go button. Go button. Really, job, yeah, it's okay. Yeah. All right, successful, right? UniversityDB, you can see all the total 5 tables, all 5 tables here. Okay. Ready. Now we can run our sample project. Yeah. So last 2 minutes, let me run it. Okay. In order to run it, let me create a project first. Yeah. File, new project, PHP project. Okay. Yeah. Here, we need to give a name for the project. Okay. So I call it University View. Because we only view data in this one. View. University View. project. Okay, next, yeah, everything we accept, and this one we just finish. Okay, all right. Then we just copy our main PHP file. Yeah, so we do not need to use the index.php. We just copy this whole PHP file into the source file folder. All right, yeah, copy paste. Okay, all right. Then we can run it. Yeah, here let me open it to see the code. Okay, yeah, so that's the code. Yeah, all right. Yeah, so all right, so let me run it. Okay, before we finish this class, we want to see what happens. Right click, run. See? Yeah, you see the data, right? This is the data from the student table. All right, one student, but not for this class, for another class. All right. Yeah, but if you click the links of other tables, so you see the data from other tables. So that's simple, okay? So this is our first sample project. Yeah, so you just study, okay? Yeah, so later, so next class, I may use a few minutes to explain the main code. Yeah, a few lines in the main code, okay? All right, so that's it. Yeah, let's stop right here.